and gentlemen, I am going to be walking you through Unit 2, Notes 1. Before we do that, I do want you to update your table of contents. So we did 4 notes in Unit 1. This is now the first set of notes for Unit 2. So go ahead and make sure you title your topic and you write Unit 2 on your table of contents. All right, so we are going to be sketching this table in our notebooks. If you are in class, you should have gotten pictures of the periodic table. I did provide for you cutouts of each of those different scientists' periodic tables so that you can glue it into your notebook. So if you're not in class, then just go ahead and fill in the scientist, the year, and the description of their periodic table. And when you come back to class, you can go ahead and paste that in. Okay. All right, so we have 4 different scientists that we're going to be walking through, and this slide here just provides an overview of the year that they came up with their table, and then also the description of what their table looked like. So we're going to go ahead and get started with John Newlands, who is our first scientist, and he arranged the periodic table in order of their relative atomic masses. He published the law of octaves, which says that an element will exhibit similar behavior to the 8th element following it in the table. And he arranged all of the known elements into 8 groups of 7 by atomic weights. So this picture here, we can see that there are 8 groups. They are all going down. So we have 1, 2, 3, 4, 5, 6, 7, and 8. And the elements, there's 7 of those elements in each group. So that's how we come up with the law of octaves, because he's saying that every 8th element is going to be exhibiting similar behavior. So he's saying that hydrogen is similar to fluorine. Fluorine is similar to chlorine. So that is why he arranged his table like this. So for John Newlands, some of the things you need to know is he organized it by atomic masses, and the law of octaves is what he is known for. All right, our next scientist is Lothar Meyer. This was just 1 year later. He still organized his elements by atomic masses, just like John Newlands, but he also arranged them by their valence electrons. So if we look at our periodic table here, we can see in this first group, he has carbon, silicon, tin, and lead. So he's putting all of these elements in this column together because they all have the same number of valence electrons. So he is saying that elements that have identical properties are occupying nearly identical positions on the table. So make sure that when you glue this in your notebook that you are making reference to carbon, silicon, tin, and lead. They all have the same number of valence electrons. Nitrogen, phosphorus, arsenic, and antimony and bismuth, they all have the same number of valence electrons. Okay, we're going to learn more about valence electrons in the next set of notes, but just understand that Lothar Meyer organized his periodic table by valence electrons. Okay, Dmitri Mendeleev, he came in 1869. He is also still organizing them by atomic mass. However, he's now looking at elements' chemical properties. So if you look at his table, we can see that this here is a vertical column, but he left a lot of empty space in between these 2 elements. So he's very well known for leaving these empty spaces. So if there's anything that you are really to remember about Mendeleev, is that he did leave these blank spaces because he knew that we did not yet discover some elements, and so he wanted to leave space for them. And then Henry Moseley, he is the last scientist here. He is what we think of the modern periodic table. So when you think of his last name, starting with M-O, think about modern M-O. That might help you remember that he is the last scientist to really design it and make sure that it is arranged by increasing atomic number. So all of the other scientists had arranged it according to atomic mass, but he was the only scientist to realize that this is how it needed to be arranged in order for all of the prior discrepancies to be explained and to be fixed. So if you look at your periodic tables in your classrooms and the one that I'll be giving to you in class, you'll see it looks just like this. These numbers that are at the top, those are corresponding to the number of valence electrons. So we have like lithium, sodium, potassium, all of these guys here. They're all in group 1 with 1 valence electron. So we can see beryllium, magnesium, calcium, they're all in group 2 with 2 valence electrons. Now ignore the 0 here because that does not explain the 0 valence electrons. Every element here is actually going to have 8, so don't worry about that so much. But so there you have it. Those are the 4 scientists that helped us with the development of the periodic table. What you need to know are whatever I have in bold with each scientist, and also make sure that you can look at the picture and match each scientist with their picture.